and beloved Eugene Merman. So we're having nothing but fun here on StatTalk this week. We're talking about life on other worlds. We're talking about space science superheroes. And this segued into this search for life. And now we're talking about how we exactly would actually go looking for life. We have some assets there on Mars right now, right? We have the Curiosity rover. We still have the Opportunity rover. We have a lot of assets in orbit around Mars. And the idea, let me just start by going back to start with. Why are we all so hot to look for life on Mars? Why not life on Mercury or Venus?
Close by, Mars is the best place to look for life. And then we get further out into the solar system, and then we go to these ocean worlds, which even look, better. But again, Earth and Mars really are sister planets.
And it looks like Mars was once wet.
It's the most Earth-like environment on the surface of another planet that we know of. And we have a lot of evidence that in the past it was much more Earth-like. So,
do we have a sense of why it's so sad there now?
Yes. It's not as big as the Earth, so it cooled off faster. So it does not have the churning iron in the middle that we have on Earth, creating a magnetic field, which makes the solar wind particles go downhill when they get to the North and South Pole. But on Mars, apparently, these same particles scrape the atmosphere off. Scraped it into space.
So it lost its atmosphere. It ablated. You can see it. It's still going on today. Our MAVEN spacecraft is in orbit. Check out,
And you can see the atmosphere.
We can see the ions ablating. It's only 1% atmosphere. Mars has a 1% compared to Earth. 100% here has 1% in its carbon dioxide.
Yeah.
So
it lost its air.
It's not protected by that
it lost
magnetic
its
field.
water.
Is there
We're still
any way
trying to
to put
figure
an
out when
atmosphere
and
back
how.
on?
So hang on. How are we going to get there, you guys? We just had a Humans Orbiting Mars workshop. The Planetary Society pitched a Humans Orbiting Mars architecture, as it's called. And along with all the many things NASA was going to do was develop these solar electric propulsion spacecraft. And how does that work? And the solar electric was going to go out to an asteroid, the asteroid redirect retrieval mission, right? How does solar electric propulsion work, and how is it part of going to Mars?
Right, so when we go to deep space, we get back Earth, Moon, cislunar, right? That's the next step. That's phase 2. First on space station, low Earth orbit. This 2020s will be on our Space Launch System. That's our heavy lift launch.
Space Launch System is a NASA word for big rocket.
Big rocket. Big rocket. We haven't had one like this for 40 years. Move over Saturn V. It's more powerful.
More powerful than a Saturn V.
These rockets, these are made of your standard metals. Your tin,
Yes.
your standard.
That's a great question, Joe.
Yeah, using aluminums, using additive manufacturing though to make it's much more efficient. So we're using high tech but big rockets.
But we're basically using Home Depot stuff. We're using the screws and the.
Yes, nice stuff.
Yeah,
Some
nice,
titanium.
high end.
Yeah, you got to go to that
Imagine
aisle
the
way at the
fanciest
end.
Home Depot you can and double it.
And then we get out to cislunar. So now we're in deep space, okay? We're in deep space. Not quite yet to Mars. Yeah, that's phase 3. But in phase 2, we're into deep space, and we have to demonstrate some technologies. Because you don't just get to Mars in one
No,
leap.
but here, let me just tie
space
this in.
electric propulsion. You want to know, in space propulsion.
But here's the
solar
thing, as
electric.
Joe just said, Home Depot style rockets, chemical rockets. That's what you know what I mean, Joe? You got a liquid oxygen, you got some other fuel, you mix them with a fuse, and they burn like crazy, and they make that cool noise, and then they go into space. Shh, but it's usually
Really rapid.
And then what happens after that?
Then you're in space, and there's some reason you don't want to use chemical rockets anymore, and that is?
Well, we need breakthrough technologies, so we need new technologies. So what we're investing in now we're getting to the moon, right? So you're deep space. Our top technologies we're investing in today.
But isn't it that
in space propulsion?
It's hard to carry all that much
It's hard to
fuel,
carry
right?
cargo and fuel. It's
So what
got
is
a
the
gravity
in-space
well.
propulsion
In-space
consist of?
propulsion, so there's different ones, but so
We
we're
had
talking
gone
about
to
solar
college.
electric
We
propulsion.
would have met cool people like
That
that.
can move big cargo,
So many good
lots of
people.
mass, heavy mass, goes slowly, but that's all right. We'll get there. So it moves a lot of cargo. You know, you're
And
going
it
on a
works
camping
slowly.
trip.
We're rockets in space.
Yeah, we're 17. Yeah, we're more than 17,500 miles per hour, but still slow for space. Slow for
Oh wait,
slow for
so how
space
fast
speed.
is faster space for us?
Well, light speed is fast, right?
Yes.
Yeah.
Sorry, but meaning when
Joe.
you say slow, you mean as fast as we can make, not
Yeah,
like where.
slower. Let's say a little bit, a little slower, because you want to get your people there as quickly as possible. So big rocket, let's go fast. About 8 months. That's fast for us. Punch it. 8-month trip because we got to get boots on Mars. We get orbit. But this in-space propulsion, solar electric, that's a nice candidate. Constant acceleration, so just keep going all the way.
Does it
Let's
get faster and faster
carry
as
your
it goes?
groceries. Carry the stuff you need with us. We always bring a lot of stuff.
Does it arrive later after the people? or
Well, we can be
before?
popping them off, right? So if we
Yeah,
get
so
this
what we want to
capability,
do, what we want to do is have stuff in place before humans show up. We want to land some tents.
and fuel depot, as we said, habitats. So that's what we're
But
investing in.
I just want to talk for a second about the rocket equation. Who doesn't?
Oh, I love the rocket.
Yeah, so the big thing that makes a rocket go, and you've seen this, Joe, is the stuff coming out the back is going really fast.
The classic orange in a child's drawing.
Yes.
Yeah, afterburners. Yeah, that's it.
Yeah.
The orange.
So it's going really fast out the back. But you need a lot of fuel, and you reach a point where you can't get the rocket going too much faster because you can't get the exhaust going that much faster. Right?
That's called specific impulse. So
Yeah.
that's what we call it in the rocket equation.
So in solar electric propulsion,